In the name of Allah, the most gracious, the most merciful, here we have to deal today with our new program online using Tabarak website, Tabarak school website with you, teacher Mohammed Albadry, grade 9 mathematics teachers here. And
in the name of Allah, the most gracious, the most merciful, I am Mr. Mohammed Albadry, teaching grade 9 bilingual. Welcome to our private school Tabarak from our educational platform. We have to thank our chairman, Mr. Yunus Al-Rahbi, who gives us this wonderful chance to contact with our dear students. Our lesson of today is talking about a cyclic quadrilateral, and we have to know what is the properties of a cyclic quadrilateral. The properties of a cyclic quadrilateral are as follows here. The first property, a cyclic quadrilateral has all its vertices on the circumference of the circle. Here if we see this figure, we will see that all of these four vertices lies on the circumference of the circle, not outside, neither inside. It must lies on the line of the circle. And the second property is the sum of the opposite angles of a cyclic quadrilateral is supplementary, and we know that supplementary is the sum of the angles, the opposite angles add up to 180. So measure of angle BAD plus measure of angle BCD equals 180, and also measure of angle ABC plus measure of angle ADC equals 180. For the third property, if one side of a cyclic quadrilateral is produced, then the exterior angle so formed is equals to the interior opposite angle. That means here we have CB is a side and CE is the extension of CB. So we have here an exterior angle APE. It is equals to the opposite interior angle, or the interior opposite angle ADC. Not angle A, neither angle C. It must equal to angle D. So angle D equals to angle ABE, the exterior angle. For example 1, for exercise 1 here, AB and AC are tangents to circle O. Prove that ABOC is a cyclic quadrilateral. So if we have AB and AC are tangents to circle, we know these two tangents from an exterior point. So we will have OC and OB two radiuses. So what is the relation between OC and AC? Are perpendicular, yes. So AB perpendicular to OB, radius is perpendicular to the tangent from the contact point, and AC perpendicular to OC, the same idea. Radius is perpendicular to the tangent from the contact point. So we have two right angles, angle OCA and angle OBA are right angles. So each one of these two angles equals to 90 degrees. So in the quadrilateral OBAC or ABOC, we have the sum of the opposite angles equals 180, because angle C plus angle B equals 90 plus 90 equals 180. Opposite angles are supplementary. So we know that the sum of the interior angles of any quadrilateral equals 360. We have one pair equals 180, so the left pair equals 180 also. So the opposite angles are supplementary, because angle O plus angle A equals to 180. So here's the opposite angles, the sum of the opposite angles equals 180. So the quadrilateral ABOC is cyclic quadrilateral. And for example 2, for exercise 2, from the opposite figure, prove that ABCD is a cyclic quadrilateral. How could we prove it? Here we have two triangles. The first triangle is ABC. How could we find the size of angle B? It's easy to find it. We have measure of angle BAC equals 30, measure of angle BCA equals to 80. So measure of angle B equals 180 minus the sum of 30 plus 80. Why? Because the sum of the interior angles of any triangle equals 180. So measure of angle ABC plus measure of angle ACB plus measure of angle BAC equals 180. And we are going to replace the sizes. Now here we don't have the size of angle ABC, so measure of angle ABC plus 80 plus 30 equals 180, and we will find the sum of 80 plus 30, 110, and move it to the other side. It will be 180 minus 110, so it will be 70 degrees. Again, in triangle ADC we will do the same to find measure of angle ACD. So measure of angle ADC plus measure of angle ACD plus measure of angle DAC equals to 180. We are going to replace the sizes now. Here it will be 50 and 110, and we don't have the size of angle ACD. So 110 plus 50 equals to 160. Move it to the other side. It will be 180 minus 160 equals 20. Now ABCD is a cyclic quadrilateral. Why? Because here we have 110 and here we have 70. If you add them, it will be 180. No, we cannot say it like this. Here we have angle B equals 70 and we have angle D equals 110. So 110 plus 70 equals 180. And now for the homework. From the given figure, prove that ABCD is a cyclic quadrilateral. The same idea, we are going to find the opposite angles. The sum of the opposite angles, it will be 180, and do it, but you have to do it yourself, and we will see it when we return back to our private school. And I want to thank you for your listening, to say bye bye. See you in next lessons.
Thank you for listening to our explaining, and I hope that you enjoy our explaining now. And the homework, you can find it on the website using the Moodle program. Thank you very much.